Hey boys and girls, this is 10.2, Finding Probability of Events. Now when we talk about probability, we talk about the likelihood an event will happen. So what's the chances that it'll happen? So when we talk about probability, it's always going to fall into this range, anywhere from 0 to 1, all right? Um, Now zero, something with a zero probability of happening is impossible. It cannot happen. For example, if I said to you, hey, what's the probability that when you flip a coin, it's going to land on a 7? Well, the probability of that is 0 because on a coin, there's a heads and tail. There is no 7 or any other number on it, right? So now that means there's a 0% chance. There's a 0% chance of that happening. On the flip side, if I said to you, what's the probability that if you roll a number cube, so you think of a number cube, it's, it looks like this. It's got like a 1, a 2, a 3, it's got 4, 5, and 6 too. All right, if you look at a standard number cube, what's the probability that when I roll that number cube, it's going to land on an integer? So an integer is something like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Well, that's definite. That's definitely going to happen because all the numbers on a standard number cube, 1, 2, 3, 4, 5, and 6, are integers. So that's definitely going to happen. There's a 100% chance that's going to happen. Now, something here in the middle, it's like 50-50. There's a 50% chance it's going to happen because there's an equal chance that it will happen or that it won't happen. So these are like three kind of markers, but obviously most of the things that we're going to talk about are going to fall someplace in here, right? Not exactly on the 0, the 1, or even the half. Sometimes it will, but most of the time they won't. So now when we think of probability, we're going to think of a fraction. And sometimes we're going to write them as percents, but we're going to think of it as a fraction. The fraction looks like this: favorable over total. So what I mean by that is favorable outcomes over total outcomes. So I'm just going to write that from here on out as F over T, favorable over total. Now sometimes in your book might even use the word successful instead of favorable. So sometimes you might see successful outcomes over total outcomes or favorable outcomes over total outcomes. It's the same thing. So let's get started. So for example, number 1, you flip a coin. What is the probability the coin will land on heads? So again, if we think about probability is favorable over total, so what are the favorable outcomes for landing on heads? That's easy. That's just heads. All right. And what are the total outcomes? When I flip a coin, it could be heads or tails. So in other words, there is one favorable outcome and 2 total outcomes. So the probability of me landing on heads when I flip a coin is 1/2. For example 2, what's the probability the coin will land on both heads and tails? Well, that's going to have a probability of 0. That cannot happen because if you think about it, when you flip a coin, it's going to land on heads or it's going to land on tails. It can't land on both. That's an impossibility. Let's look at number 3. So you roll a fair number cube. So a fair number cube means it just has the numbers 1, 2, 3, 4, 5, and 6. There's no trickery to it. So you roll a number cube. What's the probability of landing on a 4? So favorable over total. Well, there's only one favorable outcome, and that's landing on a 4, right? But what are the total outcomes? What are all the outcomes? So if I roll a fair number cube, I can roll a 1, a 2, a 3, 4, 5, or a 6. So that means the probability of me landing on a 4 is 1 favorable outcome over 6 total outcomes. So the probability is 1/6. Moving on to number 4. You roll a fair number cube. What's the probability of landing on an even number? So let's think of all the favorable outcomes to landing on an even number. There could be, I can land on 2, 4, or 6. And again, the total outcomes are 1, 2, 3, 4, 5, and 6. So, therefore, I have 3 favorable outcomes over 6 total outcomes. Now, when we are given the probability of something, we're always going to reduce the fraction if we can. So 3/6 is the same thing as 1/2. All right, so the probability of landing on that is 1/2 or 50%. All right, number 5. So you roll a fair number cube. What's the probability of landing on a number that's greater than 4? So we have favorable over total and a number greater than 4. So let's think of the favorable outcomes to that. So greater than 4 means it can land on 5 or 6. And the total outcomes, again, are 1, 2, 3, 4, 5, and 6. So the probability is 2 favorable outcomes over 6 total outcomes. And again, this 2/6 can be reduced to 1/3. So the probability of that happening is 1/3. Now, something I just want to note. You might be able to go ahead and when you think about this problem, notice how I always start by writing the F and the T, favorable over total, and then I'm listing the outcomes for the favorable outcomes, and I'm listing the total outcomes, and then I just count the numbers up. You guys will certainly get the hang of it, and you don't have to. You can always do it like this too, but you guys just get the hang of just think, okay, well, what are the numbers that are greater than 4? There's 5 and 6. Sometimes it seems like a tedious thing to write everything out, but I'm just doing it just so we understand it. But certainly if you understand it and you could, just get from here to there, that's okay too. All right? So, number 6. What is the probability of spinning a prime number? So I have the spinner over here. Oh no. I probably should have. Hold on. Let's do this. I'm going to edit this out. So what's the probability of spinning a consonant? Okay. So it's probably of spinning a consonant. So a consonant, if you don't know, is the opposite of a vowel. So the vowels are A, E, I, O, U, so everything else is a consonant. So what's the probability if I have the spinner that it lands on a consonant? So let's go favorable over total. So favorable, so what are consonants here? So B, C, D, F, G, H. So B, C, D, F, G, and H are all consonants. And the total outcomes are A, B, C, D, E, F, G, H. So A, B, C, D, E, F, and H. Now E, F, G, H. I don't know my alphabet. G, H. Perfect. So what are the favorable outcomes? We have 1, 2, 3, 4, 5, 6 favorable outcomes. And we have 8 total outcomes. So the probability of me landing on a consonant is 6/8 or 3/4. So just to take this a little step further. So what this means is in theory, so this is just all in theory. So in theory, if I spun this thing, this spinner, 4 times, in theory, 3 out of the times it would land on a consonant, right? Now, it won't always do that, much like if one of the first questions said, what's the probability of landing on heads, right? So what's the probability that you'll land on heads if you roll a number cube? I'm sorry, a coin, if you flip a coin. So the probability of that is 1/2. So that means every 2 times you do it, 1 of the times it's going to land on heads. But again, that's just in theory. There's a possibility that you flip that coin 12 times and it lands on tails every single time, right? But if you look at something like 3/4, the probability of something is 3/4. Well, if we go up here to this, remember we had a 0 up here. This was 1, and this was 1/2. Well, 3/4 is right here. So that means on this scale here, this thing that's 3/4, it's got a greater chance of happening than not happening, right? So it's almost going to probably happen. Okay. Number 7. So you randomly pick a marble from a bag. The bag has 2 red marbles, 7 blue marbles, 4 green marbles, and 5 yellow marbles. Event A is picking a blue marble. Find the probability that event A will occur. So the probability of event A, again, we're going to look at this as favorable outcomes over total outcomes. So the favorable outcomes of picking a blue marble, well, there's 7 blue marbles. So the 7 outcomes that are favorable to that. Now, there are 2 red, 7 blue, that's 9, plus this 4 is 13, plus this 5 is 18. All right, so that means, so there's 18 total outcomes. So 7 favorable, 18 total. All right. For the next one, you randomly pick a marble from a bag. The marble has 2 red, 7 blue, 4 green, and 5 yellow. Event B is picking a blue or a yellow marble from the bag. So what's the probability of that? So the probability of event B is written as favorable over total. So the favorable outcomes, we're looking for blue or yellow. So there's 7 blue and there's 5 yellow. So that means, so 7 and 5 is 12. That means there are 12. That means there are 12 favorable outcomes. And again, same problem as before, same numbers, there's 18 total outcomes. So the probability of this happening, of me picking a blue or a yellow marble from the bag, is 12 out of 18, or I can write that as 2/3. Because 6 goes into 12 2 times, 6 goes into 18 3 times. So write your answer from number 8 as a percent. Well, 2/3 is a percent. I could just do, we could just, hopefully 2/3 is one of those ones that we know that's equal to 66.6 repeating percent, or 66.7%, because this goes on forever, the 66.6. So let's just say that's going to be 66.7%, or we can even round that to 67%. All right. So the next thing, number 10, last one. So there are 24 blue markers, 16 yellow markers, and 16 yellow markers in the drawer. If you randomly choose one, what's the probability of picking a yellow marker? Express your answer as a percent. So when I ask for a percent, I like to just put it as a fraction first and then go from there. So if we think about it, so what's the probability of choosing a yellow marker? So if we're looking at favorable over total, favorable outcomes, yellow markers, there's 16 of them, right? And then there are 24 blue markers, and again, we have 16 yellow markers, so that means we have a total of 40 markers, because 24 plus 16 is 40. So those 16 of the outcomes are favorable to picking a yellow, and there's a total of 40 different outcomes. I could choose any one of those 40 markers. So 16 over 40, we can reduce this. 8 goes into 16 2 times, and 8 goes into 40 5 times. So the probability is 2/5. Now, if I want to write that as a percent, I could just do 2/5 times 100, which equals 200 over 5, and 200 divided by 5 is 40. So that's 40%. Or I could have just done 2, got a calculator and do 2 divided by 5. I would have got 0.4, and then just multiply that by 100 to get that 40%. Either way, that works. So that's probability. If you guys have any questions when you're doing the assignment, please just send me an email and let me know.